Here we have the vector space P upon polynomials of degree less than 3. We have two base S and T. For this vector space, we need to find a transition matrix from T to S and from S to T. We call that the S. This basics is standard basics for this vector space. Okay. Because any recall that polynomial of degree less than 3, right? This set, sometimes we also write as R2 or R3, say R2 X, right? P3 actually the set of all polynomials, say A0, A1X, A2X squared, right? This one. Or we can write for consistent, we can write R3 and think of it as degrees less than. So this equal to this set of all polynomial in X degrees less than 3 or less than equal to for A0, A1 to a real number. Yep. So recall this, and this basics is a standard basics because any polynomial can be written as linear combination. So A0 times 1 plus A1 times X plus A2 times X squared, right? So this is standard basic. Anyway, we need to find the transition matrix from T to S. So recall that the transition matrix from T to S, this is a matrix where the first column is the coordinate of T1, the first vector in the basics, T with respect to S, T2 with respect to S, T3 with respect to S. So vector T1, T2, and T3, and T1 here is just 1. Okay, we write down. So T1 is just 1. With respect to S is this basics. T2 is just 2x with respect to S, and T3 is 4x squared minus 2 with respect to S. 1 with respect to S, so the coordinate of 1 is just 1. So 1 equal to 1 times 1. 0 times x. 0 times x squared. The coordinate of 1 with respect to S is the vector 1, 0, 0. 1, 0, 0. Similarly, we can find the coordinate of 2x and 4x squared minus 2. 0 times 1, 2 times x, 0 times x squared. The coordinate of 2x with respect to S is 0, 2, 0. And the last one is, what it is, 4x squared minus 2. 4x squared minus 2. So minus 2 times 1, 0 times x, 4 times x squared. 4x squared 2 the coordinates with respect to basics S is minus 2, 0, 4. Okay, and now we put all of them together here, we get the transition matrix, right? Transition matrix P from T to S. Just first coordinate, put it in the first column. The second coordinate, put in the second column. And the last coordinate, put in the last column. Yep, and we have a transition matrix from T to S, and the transition matrix from S to T is just the inverse of the one from T to S, and you need to compute the inverse of this matrix. And the result would be, this is the result. We can do by all the methods we know in the last chapter. So what is this? This is 1 0 0 0 1 over 2 0 1 over 2 0 1 over 4. Okay, so this is how to find the transition matrix. But now we didn't do it for vector space, Euclidean vector space, but we do it for the polynomial vector space. But the method is the same. We need to find the coordinate of the first vector in T with respect to S, and so on.